All right, so let's get started. Hi, everyone. My name is Shohei Kawano. I work at a company called Cyber Agent, which is based in Shibuya, Tokyo, Japan. And today I'm going to talk about Flux, which is an architecture originally for web applications. But today I'm going to talk about it specifically for Android development. And since I have been developing the app with Flux architecture for almost a year now, I also would like to share some of the things that I felt or noticed about Flux architecture through my experience as well. But before I begin, I'd like to ask you guys some questions. How many of you have used Flux before, either for web applications or Android applications? Raise your hand. Or only a few. How many of you have used it for Android? Only one, or yeah? Oh, that's great. I hope I can teach you something new for Flux architecture for all of you guys. Okay. So to start, what is Flux? From the basics, Flux is an architecture introduced by Facebook in 2014 at F8 conference. It's originally for building client-side web applications, but nowadays people in Japan, from I know, started using Flux architecture for Android as well. And the main concept for Flux is that the data flows in one direction. And the official documentation for Flux architecture also mentions that the most important concept is that data flows in one direction. So how the flow of data looks like? Well, it looks like this. This is the simplest diagram of Flux architecture, and it's also in the official document. And for this session, I modified it a bit, and the flow actually looks like this. We have 5 components, and we're going to take a look at each of them later. So let's introduce some of the components. So I'm going to briefly and quickly explain what each component means and what each component is responsible for. First, starting the view. View, as you can guess, responsible for rendering UI, but how it renders UI is based on what's called store components, state, and values. And so therefore, a view is responsible for subscribing to stored state change. But a view itself doesn't have any state. Next, action creator. It's a kind of a helper class. What it does is it creates a so-called action component and passes that action to dispatcher component. And that's it for the action creator. So action creator doesn't have any state as well. Next, it's action. Action is kind of a container class. It holds data or can be a description of the new state for the store. Action can be created by action creator, and it's going to be dispatched through dispatcher to store. So action is there for delivering new data or new state to store. Next is dispatcher. Dispatcher is a central hub for all the data flows in Flux architecture. Once dispatcher receives action and dispatcher dispatches action to store, the data flow starts. And that's it for the dispatcher part. Dispatcher, so therefore, doesn't have any state as well. And finally, the store. Store is the only state manager in your application in Flux architecture. And it has states and the data and the logic of your application. And it changes its data and state based on only by receiving actions from dispatcher. So store is the only state manager in your application. And this is important, so I just wanted to clarify. As we go through, you may wonder like in which component, like action creator or store, you need to put the logic inside. When you wonder, the store is the place where you need to put logic or state. So these are the 5 components of Flux architecture. And Flux is all about having unidirectional data flow using these components. But why do we have to create these unidirectional data flow, 5 separate components, and the store as the only state manager? Well, there are several benefits that I can come up with. Like the diagram itself is pretty simple, and you know where to look when there's something wrong with it, or the code will be consistent throughout the application. But one of the benefits that I like the most about Flux architecture is that it makes your app dry. Dry means don't repeat yourself. So we will look into the details later, but by defining 5 separate components and the store with the only state manager, when you try to scale your application, for example, by adding new feature or new screen, you may realize that you can reuse some of the already defined components and the logic inside the store so that you have less code to write and more time to focus on feature development or coming up with new idea to scale your application. Okay, so having said that, let's see how we can construct the Flux data flow first using a simple example. So let's imagine that we will need to make this kind of screen where it shows that you a list of user using Flux architecture. And for this example, I use some of the libraries. Don't worry if you are not familiar with some of the libraries. These libraries are not necessary for creating Flux data flow, and I will share some of the alternative libraries that you can use other than these as we go through. Also, we go through declaring the Flux components, and we're going to do like some code jump, and I'm going to show you a lot of codes, so don't be panicked. We're going to go through each of the components step by step. Okay? So, I want to drink water. Okay. So in Android, there's a screen that opens up when user launches the app, right? And this screen is considered as view component in Flux architecture. In Android, activity, fragment, or recycler view, custom view, or any other things, all kinds of views can be considered as a view component in Flux. So let's say in our example, we have activity and we have onCreate. We need to implement onCreate implementation. So this code is an activity for showing a list of user, and we use data binding to bind the layout. So let's see what's inside the layout file first. So this is the XML file. We have a variable declared is loading variable with a Boolean type, and we have recycler view and progress bar. And notice that progress bar, the visibility of progress bar toggles based on the is loading value. Okay, and to start, let's assume we use Dagger to inject all the necessary fields. And I already injected some of the fields. Don't worry, I'll explain it each later. So we have action creator, a loading store, and recycler adapter already injected in the activity. And in view component, we have 3 steps to do. We initialize view, and we subscribe to state, and finally we call action creators functions. And let's see each one by one. First, initialize view. It's a very simple step. In initialization view step, we like set onClick listener or recycler view, set recycler view adapter, and so on. It's a simple step, and that's it. For subscribing state, let's say we subscribe to loading state, and here's the code. We have loading store injected into the activity, and loading store has so-called loading state property exposed to the activity, and we subscribe to it. And we use auto-dispose library to automatically dispose the observable on activity on the short lifecycle, so we use auto-disposable in this case. And we pass the value, so that either true or false will be streamed down to activity, and we pass that value to is loading variable that we defined before. And we notice that in order to have more space in the slide, I'm going to extract these things into private functions. So the activity now looks like this. It's pretty simple, right? And finally, we call action creators functions. So we call, in this case, action creator dot show user list is a function call of the action creator. And that's it for the view component. And next, if we go back to the diagram, let's move on to action creator part. So we already called the action creator part. So from view to action creator, it's already finished. So let's now we will look how action creator creates action. So this is the action creator's code. From the top, we have API class injected inside the constructor, and we have show user list function. And inside show user list function, we call fetch user list function to get a list of user from the network. And if it's on success, we'll get the user list. And if it's on error, we get error as a throwable type. And now let's see how loading action is initialized inside action creator and how it looks like. So loading action is initialized in those places. And if you look inside the code, loading action is declared as sealed class, and it has a property activity key to determine which activity it's depend on. And we have two classes, idle and loading, to describe if the progress bar needs to show or be hidden. Next, let's see how user list action is initialized and looks like. So inside action creator class, user list action is initialized in those two places. If you look inside, we also use sealed class, just like loading action, to create classes. We have two classes, show user list and error. It's a simple class. And once we create action, we're going to pass it to dispatcher, right? So let's see how we can pass that. Notice inside user list action creator, we have dispatcher. And dispatcher has a function called dispatch. And the function is called in those places. And if you look carefully, when show user list function gets called, we dispatch a loading action. Then API call is successful, we dispatch show user list action and make loading to idle. If the API call fails, we dispatch error and make the loading a past idle loading action. And that's the flow for this action creator. And now let's see how dispatcher is implemented. This is a dispatcher class. How dispatcher dispatches something throughout the application. In this example, we use event bus. We have three functions, dispatch, register, and unregister. Dispatch function is there to broadcasting actions throughout the application. And register is to register observer for the given event to start observing. And unregister to unregister observer from the dispatcher. It's a simple class. And for dispatcher, as long as we can broadcast given action throughout the application, it can be anything. So of course, you can use RxJava, or just like in this example, you can use event bus as well. And maybe you can create your own implementation. As long as you can broadcast given action, it can be anything. And next, once the dispatcher receives and dispatches action, store will receive it. So let's see the code inside. So first, let's see what's going to happen when loading action gets dispatched. So inside action creator, we dispatch loading action in those places. And once those loading action gets dispatched, we have loading store, and loading store will receive it. Let's take a look at these codes from the top. So inside the constructor, we have dispatcher and so-called navi component, which is there to register what to do in specified lifecycle event. This is just like under the architecture components lifecycle. So inside the init function, we add what to do in certain lifecycle event. So in this case, if it's on create, we register the store into the dispatcher. And if it's on destroy, we unregister the store from dispatcher. So simple. So again, for observing lifecycle events, you can, of course, use under architecture component, lifecycle component, which is now the major library. And of course, you can use Rx lifecycle navi component to do the same thing, just like in this example. And maybe more. You can do the same thing by your own. Okay. And then, so the green robot event library has a subscribe annotation we can use. And in here, we subscribe to a loading action to be dispatched. And what's inside here, we first check the activity key to determine the loading store and the loading action that's dispatched from the dispatcher are in the same activity. And if it's same, we do something, right? So in this case, if the activity is the same, we have what's called loading subject, which is declared as published subject. And so we have loading subject declared. So if action is loading, then we pass true to the subject. And if it's idle, we pass false. Right? And now, next, let's see what's going to happen when user list action gets dispatched. So inside action creator, we have a loading action dispatched in those places and user list action as well. And then inside, this is a new store, a user list store. Looks the same or similar to loading store. And notice that we have a user list property as an observable array list. And if you have used observable array list, you need to register the callback in order to get notified if the list changes. So we expose add on list change callback and remove on list change callback from the store. And then the store also has the on function, just like loading the store, to wait for user list action to be dispatched. And then if the action is show user list, then we add the data from the action to the field, the user list field. Okay. Now finally, how you can subscribe to store state change, right? So let's see how streaming loading state change using our Java. So inside loading store, we have loading subjects and we pass true or false value. And the store also has loading state, which is the observable type. This can be done by published subject has a hide function where the subscriber subscribes to the published subject as observable type, so you don't need to care or like the subscriber doesn't have to call any published subject functions, so it exposes the state as observable type instead of published subject type. And when the loading subject has a new value, true or false, then the view will receive it. That's the where we saw the first initial code for view component. So the subscribe state, inside the subscribe state, we subscribe to loading state, and the new value will be passed in isLoading variable, and then the progress bar eventually will toggle in here, right? And for streaming user list change using data binding, remember we have observable array list, user list type, and inside the recyclable adapter, we have a list change callback declared. And just like store, we also use Navi component to detect activity lifecycle event. So in onCreate, we add the callback, and in onDestroy, we remove the callback. Yeah. And then the rest is normal, just like recyclable adapter. The get item count, on-bind view holder, and you override those things, and everything's fine. And finally, from store to view, it's already done. So finally, the Flux data flow is constructed, and we see a list of users. We saw a lot of code just to show a list of users. So I know you are feeling like it's not worth it. But when you start trying to scale your application, you'll feel the power of Flux architecture. So imagine, let's assume we need to add favorite functionality or user detail activity to this app. So we have fab icon in here. So when user clicks the icon, it's going to toggle. And if user taps the item of the recycler view, it's going to show a detail page. And the detail page also has fab icon. And if the user clicks, it's going to toggle, right? So it's a simple yet kind of difficult to implement at first. So without the library or without any architecture, you need to maybe use start activity for result and receive the value on activity for result, or maybe you decide to always fetch the latest data on resume, or any kind of thing. But let's assume how we can implement the favorite functionality for user list using Flux architecture. So inside the user list adapter that we saw before, we add another action creator called user action creator. And when the fab icon is clicked, we call action creator's favorite function. And we're going to see what's inside. Inside user action creator, we have favorite function. Just like user list action creator, user action creator calls network API. And if it's incomplete without any error, it dispatch a user action, favorite action in this case. And inside user list store that we saw before, we add another on function. In this case, the parameter is user action instead of user list action. And when the action is favorite, we're going to find the given target user with the given ID. And if there is any target user, we update the user, right, to whether it's favorited or not, so that you can implement the feature, right? Of course, you need to add some code to onBind view holder to toggle the view changes and so on, but it's already done, okay? So now you can see this. And for user detail activity, right, next one. Inside user list adapter, we inject another action creator called activity action creator in this case. And when the item of the recycler view list is clicked, we start user detail activity in here. And inside activity action creator, I put all the start activity code just to start activity, so that if you put all the start activity code of the application in one place, you only need to modify in this activity action creator class. So by creating XML file and make layouts, adjust design and so on, you see a user detail activity, right? And next, we need to add favorite functionality for user detail, right, as well. So inside user detail activity, we inject, just like a user list activity, we inject action creator and store. So user action creator is injected. So inside init view function, when the fab is clicked, we call a favorite function. That's the one we already declared in the user list activity, right? So we call favorite function, and when we go back to the list of user list activity, in this time, without doing anything, we can confirm that the data is already synced. What's happened? Well, remember, we already added the code for user list store that to find a target user with given ID, and when it receives favorite action, and if there is a user, we already update. So without doing anything for user detail activity part, we already made the data synced together between user detail activity and user list activity. So yeah, here's the code. And so by that means, therefore, we can say that Flux makes our app dry by reusing the logic inside the store and maybe the action creator as well. And that's the great part. So Flux makes the app dry, but what else, right? This is almost the end, and I will share some of the things that I personally like about Flux. The other thing I like about Flux is the code consistency. So if you go back to view component, we had 3 steps to do. Initialize view, subscribe to state, and call action creators functions. And so we exposed we extracted the function into init view, subscribe state, and do call action creator functions. And having only these 3 steps, your view components never get giant, never become spaghetti, or you will never be lost. And it's so simple. And all the activity and fragments have very similar looks and feel. Also, the action creator can be the same. If you call network API inside action creator, you may call loading action to be dispatched. And if the API is success, you pass action, you pass success action. If it's error, you pass error action. And after that, you may pass loading idle action. Action creator looks really the same as well. Also, the other thing I like about Flux is that the logic inside the store becomes the intuitive specification of your application. Using Kotlin's sealed class and when keyword, and by giving actions with the appropriate name or descriptive names, by reading the logic inside the store, you can tell how the app should behave. So inside the store, that's the code we already wrote. So as we read the code, looks like it. I feel like reading the English above the sentence. So like when given action is loading, the next loading state is true. If the action is idle, then false. So it's kind of intuitive. Also for the user action, when given action is user's favorite action, then find target user from the user list and update as favorited, if there is, right? So I believe the logic inside the store can be the clear specification of your application. And if new team member joins to a team, it's easy for them to follow what's expected by reading the store's logic. Also, I talked about the great things about Flux, but there are some pitfalls and solutions for that, so I'm going to share that with you as well. The first one is dispatcher, right? As Alice told in the previous session, the event busting, right? Event bus or similar mechanism is kind of hated because it can be abused. But remember that in Flux architecture, the event bus, the dispatcher and store is the only place where we need to use event bus. And I think in Flux architecture, it's kind of difficult to abuse the event bus functionality because dispatcher and store is the only place where we need to be coupled. So, and only the action will be dispatched throughout from the dispatcher. So I think in Flux architecture, there's no problem for that. The other thing is that you may wonder in which component, action creator or store, you need to put the logic inside sometimes. For example, if you get the data from the shared preferences, you can certainly write those kind of logic inside action creator or store, right? It's easy to write. But remember that the store is the only state manager in your application. And there's a great point to specify only the store as a state manager. One is that the store can be reused with the up-to-date internal logic throughout the application. So when the logic needs to be changed, you only need to care to modify the store, not in any other places. So it's easy to find where to change. And if you have logic inside both action creator and store, then if a new team member joins your team, then it will be difficult for them to determine in which component you should write the logic inside. So it's kind of difficult for them as well. So I strongly recommend that you need to remember that the store is the only state manager and the logic holder in your application. Okay, to summarize, Flux is all about having unidirectional data flow throughout the application using the 5 components. And store is the only state manager in your application. And finally, by making use of Flux architecture, I think it makes your code dry and consistent, and the minimal boilerplate, there is minimal boilerplates to your application. So I think with these benefits, I believe Flux architecture is one of the solid solutions for managing state in Android development. And with this, we can scale our application much faster than ever. And I kind of finished in 28 minutes, but that's it for my talk. Thank you very much, and enjoy the rest of the conference.
We have time for questions.
Before you ask me questions, please speak slowly, because I'm not a native English speaker, so and I don't want you to repeat the questions. So yeah, that would be very helpful if you speak slowly. But.
So how can I use different store per activity? So I want to start a new activity, and I will provide a store for it. How do you give them 2 different store?
2 different store, meaning, so when you
Same activity with different store.
It is possible?
All the same activity. Yes, if you use Dagger, so in this example, we use Dagger. So in Dagger, you can specify the life cycle of the component. So in this case, let's see. So this is a user list store, and we annotate the store with per activity. So in this case, the user list store is separated for each activity. So you don't need to care, even though user list store is the one store, you provide the different store for each activity. So if the scope of the store is per activity, you can provide each activity the same store but a different lifecycle.
But if we don't use Dagger, then I want to use same activity with different business logics.
Huh.
So it's little hard with Flux, I think.
So you don't want to declare a new store or reuse the store?
I want to use the same activity with different stores. So it's
I see. Yeah, in those cases, you need to define new activity, I guess.
yes. I want to write a new activity for that.
Or you can inject two stores in the activity, but I wouldn't recommend that.
Okay, thank you.
Any other questions? See one in the corner.
Last Santa.
So I know Flux is often kind of relates to the Redux architecture. I'm wondering if you can talk about kind of what kind of changes there, or kind of what other things you can do.
In my understanding, so Redux is kind of Flux architecture, but the difference is that Redux has only one store throughout the application, whereas the Flux, in Flux you can declare multiple stores, but in Redux you only have one GOT store, and so I talk a lot about this, where maybe we should use Redux or Flux, but Redux is, I personally think that Redux is not good for Android because you need to manage the states all of them in only one store, and you need to put every data and state inside the memory, which may be heavy. So in my understanding, that's the only difference, or yeah.
You.
Seems we have a follow-up question.
When I navigate to background, take the application to the background, how the store get stored?
Sorry, what was the question again? How the store?
When I take the application to background, how can I store the store? Persistence.
So yeah, in this example, this is a simple example, so I didn't care too much about that. Of course, in right now, the good ways you can put the store inside. I know that there's a code that says that you can put the store inside the Android architecture components view model, so that it survives until config changes and so on.
Oh, I
And
see.
yeah, or yeah, of course you can put the store inside save state as well. Yeah.
Anyone else? Can I just have you repeat it for the room?
I was to say, I had the same question. I was wondering how you handle saved instance state inside your Flux architecture.
Yeah. So just like I mentioned, you can put the store in on saved instance state as well. But I don't remember right now. But there's a function you can put the object class to survive the object into the lifecycle as well. So you can refer to that as well. I will actually show. I will actually write the list of things that are referenced in the speaker deck, so you can maybe take a look at that as well.
Can you tell us a little bit about how this architecture affects your decisions around testing or structuring your tests?
To be honest, I'm not writing tests a lot.
That's okay.
Yeah, but there are articles and maybe the code on GitHub as well. Flux is considered as architecture that's considered as easy to test. So maybe I'll put the links and in the keynote as well, speaker deck. Yeah.
What other questions might we have for Shohei? Okay. I think that about does us then.
Okay. Thank you.